Ever since the era of classical computing, right? You are very much evident of it. What is the classical era of computing, and then the kind of problems it is able to solve today, and the power is in your hands right now, right? In your phones, the entire classical computing has come into your hands right now. So wherein you are able to solve many of day-to-day challenges to the world of gaming, which is also very uh, unknown or hidden driving factor for many of software and hardware development that happens today, right? There are primarily two things that contribute to this development or any software and hardware development. One is war, second is entertainment. So that is, in other words, I would say gaming, right? So these two are the industries that are driving the whole hardware and software development to go in a phase where we cannot anticipate. So now from the classical computing, which is our binary computation, right, to the quantum computation is the next thing that is happening. Now we have been dealing with this with zeros and ones, and now it is going to change. So it is going to change forever. It's like any other revolution that takes place from agricultural to industrial, industrial to commerce or the web world. Now I would say from the hardware side of the house, the computation, the way we compute is going to change with quantum computing, right? So as I hear from you, what is it? How do we understand it in simple words? So it is binary. That is, you are taught very well from your almost the childhood, either 0 or 1, right? So now translate your, hey, what is the value of 32 in binary? We were given all the exercises to solve, what is 2 power 5? Why 2 power 5? Because it is binary, right? We got to compute with zeros and ones only. So that's how we were taught all these years. And we continue to use them. I'm not saying that we are going to get rid of these binaries, but the quantum computing operates at a different level, not just zeros and ones, right? So even if you take an example of flipping a coin, right? So we are focusing on what it is after flipping, either heads or tails. That's our binary classic computing is about. But quantum talks about what is happening during the flip, isn't it? So what is happening during the flip? It's not just after the flip is complete, whether it is head or tail, but what is happening during the flip. It takes multiple stages between that 0 and 1. So another simplest example I found is our home ceiling fan regulators, right? The switch is binary, on or off, but the regulator, right? Not just one state. You have, at least 5 states. 0 is off again, 1, 2, 3, 4, 5. So what happens today that we are operating with 0 and 1 will change to many more states. So the quantum physics and quantum mechanics proves that the power is going to be extremely unimaginable. So that's the quantum computer that's going to bring it to us. And we, as human beings, have been evolving ever since the rockstone era, right? And now this will be the next era. Quantum era is going to be the next one, where the power is unimaginable. Now you will see why. Why do I say that, right? So this quantum computing, what we used to call as bits, now they are called qubits, right? For the continuation of that. So it's not just 0 and 1, but 0 and 1 and all the possibilities, many possibilities in between them. So it is little difficult to imagine that, but as you start to play, you will get the picture of it. Now I'm glad you have taken your first step today to get into this, right? So that's where the quantum computation is interfered with all of us. So now when this happens, the security world is going to change. We will talk about security a little bit later, but today what we have in the industry, what you can play is that, Google Willow, which is a quantum computing available as a service, which you can subscribe and start to experience the power of it, right? And then IBM is the first one to build this, what do you say, quantum computer, but it's not publicly available. So they are the ones they first built with 127 qubits. And then in recently, I think it became more than 2000 bits. And India, our goal is to build 1000 qubit quantum computer by, hopefully next year, I guess, if I read the news correctly. So we are still catching up with quantum computation. And last month, I guess, so China has released quantum OS for the first time ever. So Subbu, this might be very interesting to you. So called Origin QC. So they have released a new quantum computing operating system and it's completely open source, guys. So you should visit that, qcloud.originqc.com.cn, where you can play with it, where you can experiment with it, right? So it is happening for real. And just day before yesterday, Wednesday's news is about, Google now adjusted their prediction that the quantum computers will be live and available by 2029 itself. So earlier it was like projected after 2030, that is 2032. But now, they adjusted their prediction to make it publicly available, easily accessible by 2029. So this quantum computation, why primarily coming from quantum physics and followed by quantum mechanics. Now there is a lot of physics and mechanics involved where I think I would be the absolute wrong person to talk about it. Maybe we will invite soon. We are talking to our photonics researcher from Usmania University, who has been a doctorate into physics and photonics. So soon he will also give one session on how the light is able to give the momentum of quantum waves. So he'll be delivering that, or if not him, someone from IASC. We are talking on the same lines because IASC in India has the quantum lab. So ISC Bangalore, so we'll bring someone on board. Zini is actively working on it. So we'll go deep dive into quantum physics and mechanics at that time. So today our focus is about quantum computing, quantum cryptography, especially. So now I'm switching the gears from something like this. All your generation, what we can imagine is what a normal human being can do versus a Superman like Hulk can do, right? So where we take so much with great difficulty, we try to move a single truck or a car by using several devices, right? So as a normal human being, we need a lot of effort and intelligence to move a truck by ourselves. But when it is Hulk, we have seen in movies that he simply moves with just one hand. So that's a comparison I can bring between classical computer and a quantum computer. So what you can do today with classical computer, considered to be the most difficult task, can be effortlessly, easily be done by quantum computational power. So that's how we can imagine. Now, what is going to happen? Coming to the quantum cryptography. So cryptography is all about security, right? Why do we want to secure is a undebatable discussion. Everybody wants to secure their data, right? When you scale it with individual attention, maybe the degree is less, but when you take it to countries, right? The ongoing war, if you see, right? Russia and Ukraine, and then Iran and Israel and US. So the war is not happening on the ground. The war is happening, right, with technology. Do you all agree with that, right? So it's no more, giving a punch or using a knife or using a AK-47. It's all happening a technology fight. You don't see the armed forces on the ground and fighting. What you see is the high-end top-notch technology and the warplanes that are bombing each other, drones bombing each other. So now just imagine the security aspect of it. How important it is for a country to protect their own data, their plans, their strategies, right? So when a quantum computational power is in one country's hand, it can easily decrypt and get the messages of the other country. And hence, now that country cannot secure themselves anymore. So, therefore, what I say is that how we used to believe that all these algorithms that are based on classic computation, RSA, DSA algorithms, that everything is going to be broken by the quantum computational power. So in simple terms, I can say that. So any algorithm that you have today is based on prime numbers, right? Primarily, it is coming from the prime number. If you take a factor of, let's say, as simple as 15, right? Now, if you are given 15 and asked to find the prime number, prime factorial of it, right? We could easily probably guess. But now what happens? RSA 2048. In RSA 2048, there is a 617 digit number, and now you are asked to get its factors of prime numbers. It's for humanly it is impossible, I would say. Even when you give it to computer, the classic computer, right, it's going to take years to factor it. So that is today, guys. This is the best way to understand, right? So why the things are going to change? Now, when you give the same RSA 2048 to quantum computer, it's going to be much faster, maybe in days, if not hours. Now just imagine, so all these years what we have been thinking as secure is not going to be secure anymore given the power that is going to bring. So a 617 digit number and finding its prime factors is going to happen in now few hours. So that is the challenge the quantum computation is posing, right? It is in a way you are gaining the superpower, but superpower without any controls is much more dangerous than its power, right? You all agree to this. Now, on the similar lines, what is happening today in the whole banking industry, whole gaming industry, whole your communication industry, right? The telecom, your phone calls, your messages, everything is secured using these standard algorithms. Now, when the computational power increases to quantum, when somebody with lot of power can acquire the quantum power and decrypt all your keys, then your communication is no more secure, right? So I would highly encourage you guys to go over the basics of cryptography to understand what you are using every day, how you as an individual use it. When you even log into your mobile banking app, there's a lot of PKI, the public key infrastructure is used, right? Your private keys, public keys are used. So every time you access a secure website, you're dealing with your HTTPS, that is the application level security protocol that uses private key, public key. So security and human are inseparable, right? Now with computation of quantum, we are in danger. So how do we solve that? Now this is one more example of what happened in the past, right? And what is going to happen. So your the simple example, maybe your Aadhaar linked health records or any financial records are going to be broken. So as you know, in India, right, Aadhaar number is publicly available. You WhatsApp it to anybody, you mail it to anybody, you share it to anybody. It's not like a private thing. So if the keys can be decrypted, right? All your personal data can be decrypted by third party, those with these quantum power. And what we have today, the defense communications, the Q day, we call it, right? The quantum day, when the quantum power fully unveiled and available to public, the world is going to be chaos unless we are ready, right? So, and whatever the banking transactions, everything is going to be at stake if you are not ready with your quantum security. So quantum power is on the one side where we appreciate the power of it, superpower of it, rather, I would say. Now, on the other side, as software and hardware engineers, how are you going to be ready yourself as a backend developers, right? We are here, we are engineers. So we are here to build things, right? Enjoying it as a customer is unavoidable. We all do, we all consume technology. But at the same time, for all of you, the bread and butter is going to be our engineering, right? Be it software, be it hardware, we are going to build things. Now, already, if you see, the Shor's algorithm has proven, right, how many years it is going to take, right? RSA 2048, yeah, 300 trillion years. But on cryptographically relevant system, that is CRQ, we call it, right? So the quantum computers that are being built by countries for cryptographically relevant computers. So this is going to make a big difference where you are going to break everything. So this is proven, guys. This is in the industry live already. Now, so how do you protect yourself from it is what we need to understand. The power is growing on the other side and the security is decreasing on the other side. So you guys, as being engineers, need to be yourself available with this knowledge, with this technology, so that you are future ready. Now, how are we going to protect, right? So let's come to quantum cryptography and then understand how you are going to protect yourself. So we have multiple things here from the spectrum of quantum cryptography, right? So first we'll begin with what we have in software. So in software, what you can build is you can upgrade the algorithms, right? All these years, what algorithms that you have been using, RSA, DSA, ECDSA, right? And hashing algorithms, you would change it to use the quantum computationally powerful algorithms. So we call them as PQC. So post quantum cryptography, right? So this post quantum cryptography, PQC algorithms are the ones that we are going to develop, right? And that are going to protect our data by using encryption, decryption.
జయంతి మేడం ఉందరా
So now these are the ones. So classic algorithms now are being rolled out. PQC algorithms are being rolled out, and the NIST, the standards organization, is also approved couple of algorithms. And I would appreciate and encourage all of you to go and do the deep research into these algorithms. And I would even encourage you to go come up with your own algorithm and publish it to the IEEE standards or even NIST, where you can prove that these quantum cryptographic algorithms are going to be safe even with the quantum computational power, right? So that's how we are going to protect on the stage one with software, which can be easily developed and easily incorporated into our application, be it enterprise application or a consumer application. And what is the most important thing for any cryptographic algorithm? How do we say, why do we say that, hey, this is secure? So if you go a little bit and dissect it, the random number generation is the key. Random number generation is the key for any of your algorithms. So since the quantum power is going to make the current random number generation into a helpless state. What do I mean by a helpless state? Even when you generate using existing hardware, right, the quantum computation is going to guess that right. So when your quantum computation is going to guess that right, that means today's random number generators are not going to be truly random anymore. So that's where the need of quantum random number generator comes into the picture. Well, so now, devise a hardware that works with photons and then generates as per the quantum physics, generate this randomness. And see, this is the beauty here. Why quantum is appreciated? This has been in discussion from, decades. Quantum physics, quantum mechanics is not something new, right? It's been from decades. Now it is started to take shape in computers. The physics is understood, the mechanics is understood, the mathematical equations are defined. Only then the software comes into the picture, right? Hardware and software comes into the picture. Without the foundation of physics and maths, software is nothing. Software is nothing. So then the hardware is being built. So then this hardware is going to give the random number generation. So the beauty is when the famous characters in any cryptographic world, Alice and Bob, right? Alice and Bob are exchanging the information, right? There is a man in the middle attack, MITM, right? So man in the middle attack can still steal and use this computational power and decrypt the keys, right? So even if you are using PQC, right? And sorry, even if you are using regular classic algorithms, but the man in the middle, the hacker, can take your keys and use his quantum computational power and decrypt it. But that's not the thing with quantum technology or quantum physics. When the man in the middle, the hacker, takes your two, it always happens with the waves, right? So when they take into their control, they start to behave differently. The quantum waves are going to start to behave differently. So even the source and destination, Alice and Bob, they need to have a clear understanding between these quantum waves and agree even before they start their secure communication. Even if there is a hacker in the middle, what he gets is different because of the entanglement that happens with the quantum waves. So the quantum waves get entangled. So therefore, what the hacker gets is never the same as what the source and destination Alice and Bob are receiving. So that is making this quantum computation so different. And quantum cryptography is going to be unhackable because of that reason. Right? So far, we are relying only on mathematical equations, purely on mathematical equations. Agree? So now these mathematical equations going beyond getting into the physics world and quantum waves and particles. So that is where this entanglement is something cannot be handled. So cannot be broken. Now that is where the essence of QRNG comes. So random number generator is the one that is going to give random numbers, which is the foundation for your cryptography. And that's how you can protect all your data. And then what happens, right? That goes on. Now, where do you store or how do you make sure that, they're okay? So you might ask, hey, Venki, now you say these keys cannot be stolen, right? Because the waves get entangled. But what if I manipulate it? Right? Yeah, I'm not, I agree that I don't want the communication, the data between two parties, but I want to manipulate it. I want to tamper the data. Right. So if you look at the CIA triad, I'll just go one slide forward and come back. Right. Yeah. So if you look at the CIA triad, the most important what we talked is confidentiality and then integrity. Right. Okay. I corrupt the data between these two channels. So what the Bob is supposed to receive, he's not receiving it because I've manipulated the data. I tampered the data. So still as a hacker, you are successful. Though you did not understand what these two are talking, but you made sure that their communication is broken. Then how do you do it? Right? How do you protect yourself from the tampering of your communication? That is integrity part of CIA triad. Right? So that is with the help of QKD. Right? This is also based on your hardware device and as well as firmware that is on top of this. And then, sorry, the QKD, right? This one. And then there is something more which I've reserved it for that itself becomes another topic. In fact, we can deep dive into each one into one session. PQC could be one session, QRNG could be one session, QKD and QHSM. Each one we will roll out as a separate sessions and deep dive into this. Right. So here are the algorithms. All the engineering students. You can deep dive into these protocols, guys. So these are still these are being used today, but there is a lot of scope for innovation. There's a lot of scope for innovation. If you enjoy playing with algorithms, so these are the protocols. And here we have listed a couple of algorithms here, right? So you can take those algorithms. Kyber algorithm is already approved by NIST. So look into it and go deep into it. Well, so this is again same discussion, Alice and Bob, how they communicate with each other and what happens if somebody intercepts. So the same things are shared here, and how quantum the photons are being shared, like either horizontal or vertical. These are the two modes that they're being shared. But I don't want to make sound this webinar as a physics webinar. So we will just leave it there and move forward. And I would highly encourage you guys to go deep into this subject. I guarantee that your careers will be safe. Even with AI, your careers will be safe when you venture yourself into quantum cryptography. All right. So similarly, availability, right? So we talked about confidentiality. Confidentiality talks about encryption and decryption. So all your encryption and decryption is with your algorithms and your QRNG. And similarly, integrity hashing algorithms, right? So how do you do those integrity part of it? The data is not manipulated or tampered by someone else in the middle. How do we do that today? So we have hashing algorithm, right? HMAC is one of the proven standard algorithm. Even that is going to be broken, right? So therefore, what we try to do, same, we use the dilithium algorithm for signing, right? So this algorithm is going to make your communication integrated. That is Alice and Bob. These both share, even somebody tampers, they get to know. So that is you hash your data and generate a key. Then you also share that key to Bob. So when Bob receives the data, he writes the algorithm, right? He applies the same hashing algorithm. He writes the same hashing algorithm and then generates that key, generates the code. These both codes should match, right? Both hashes should match. So when both hashes match, that means the data is not tampered. Even if you change a full stop to comma or comma to something else, it is going to, the hash code going to be different. So that is how the integrity is achieved today. So similarly, using HMAC and ECDSA, right, it is going to be at stake with quantum cryptography. So therefore, what we already have is the crystals dilithium algorithm that is for hashing and so hashing. Therefore, you can secure your data manipulation or tampering, right? So then comes the availability. So, okay, fine, Venki. Now, okay, my data is encrypted and I can decrypt it. Nobody manipulated it. What if somebody brings my server itself down? I'm not even able to communicate, right? That's the availability part. So this CIA triad is very, very popular, and every software and security engineer must know it. It's not only for cybersecurity guys. It is for every software professional must know the CIA triad. because that's how you are being secured today, right? So availability. Now, what if somebody brings the server down, right? So you are reading your let's say keys from your cookies or your cache, browser cache. What if somebody attacks it? He doesn't know anything about your quantum algorithms and all. But what if he or she, the hacker, right, attacks on your cache itself? You cannot access your keys, right? So that's where the HSM comes into picture. Quantum HSM, hardware security module. That's a place, a hardware device where you preserve your private keys. See, this is applicable in bigger enterprises, especially in the finance industry. They must store all the private keys very, very securely. Forget about encryption, decryption, and then tampering. They should not even bring that server which holds the keys down. So the QHSM will actually help you there. So that's the availability part when it comes to your quantum cryptography. So the fundamentals don't change. Confidentiality, integrity, availability. We are not changing the dimension of security. No, we are changing how we are going to operate on top of it. Right? So this is how quantum cryptography plays a vital role in all these confidentiality, integrity, and availability. And these are the list of the algorithms for your understanding, right? What are currently available, and at Zenvi also our team is highly working on these PQC algorithms. And then when we start working on QKD, we will work on BB84 and Macauley's or NTRU algorithms. So these are the algorithms which I would say get familiarized with. And how do you play around with it today, right? So you say, okay, this is all a lot of theory. Now, how do we play around? This, you can already play around with on your laptops itself. So to understand confidentiality, right? To understand confidentiality, you can play with the public key, private key generation using your OpenSSL commands, right? If you're using Linux or Mac, go to your terminal and type OpenSSL, and you can generate keys, private key, public key, and build a sample server, client application, server application. So then use your private key with you and public key on the server that you deployed. So that's how you can experiment today in your laptops. Even on Windows, right? You can download OpenSSL and then start experimenting with this. So, and going forward, right? Once you understand classic cryptography that is available today, RSA, DSA algorithms or HMAC hashing and all, then you can switch gears and then start to experiment with these algorithms that we have listed here, right? You can still play with crystal Kyber algorithm, dilithium algorithm today. They are available. Even the browser support it in a beta mode. All right. So I think we did talk about these QRNG, QKD, and QHSM already enough of it. But now, where do you start your journey? If ever you got to begin, I would again say start with PQC and then start with QRNG. Yeah, this is very, very fascinating journey, guys. Very fascinating journey, right? So once you are hooked to security, there is nothing else in the world that fantasizes you as much as security domain does, right? So you might ask, okay, I'm a Java developer, where do I fit in? Or I'm a Python developer, where do I fit in? So applications, every application has to be ready with PQC. So let's say you have built a server, a web server. Right? Now, how do you make sure that your web server is PQC enabled? or you built a simple application, right? That application nobody buys, nobody uses if it is not enabled, if it is not security enabled. Do you agree with? Even if you built a iOS app or Android app, if that app is communicating with other apps or server in a non-secure mode, first of all, the App Store, Android Store don't allow you to upload it. Period. So you have your colleges or your institutions or enterprises have server applications. Nobody would like to become your client if this is not supporting security. Simple. So you start there. Understand how HTTP is becomes HTTPS. Right? What is the server component? Now, be it a Python application, Python server application, or Java application, or C++, or Ruby on Rails, doesn't matter. Right? Your server is being written in a language. Now, that server, how do you make it secure? How do you enable SSL? That's the starting point. Now, once you enable SSL, right? Once you enable SSL on it, now you see a challenge. You start to understand, okay, this is how it is encryption, decryption is going on. This is how the integrity is being achieved with hashing, right? This is how the availability is made what do you say, protected. So now these strategies, once you understand with existing classic cryptography, then you would start to enjoy the journey of the quantum cryptography. There are so many domains where you can, bang on with respect to gaming, with respect to defense applications, with respect to telecom applications, right? So anywhere, even as much as your college project work, your college project work should be PQC enabled, I would say. So that's how you become familiar with your quantum cryptography, classic cryptography, and quantum cryptography. So what is the opportunity? Yeah, you see that Indian government. I'm changing the gear from technology to the nation. What is the nation's call with respect to quantum cryptography or quantum mission as such? So, and so I've recently been to Singapore, and Singapore is one of the first countries to embrace the journey of quantum computing. Before anybody realizes, in 2017 itself, the Singapore has embraced the quantum computation and they started to allocate huge funds for the development of their quantum hardware and quantum cryptography. India, as little late realized, now we allocated from 2023 to 2031, we allocated 6,000 crores of budget for quantum computation, which also includes building a 1,000 qubit quantum computer. And you hear right from Mr. Chandrababu Naidu, Chief Minister of Andhra Pradesh, how much he is propagating the quantum computing. It is real. Okay, it's not about it is going to be real. It is already real. Now, what you do about it is up to you. If you want to just see, pass by, it will pass by. Do you want to make a fortune out of it? You want to make a career out of it, right? You want to, build a business on top of it? This is the time. So our goal, as I said, 1,000 qubit by 2031, which is a long game, but where we are behind as a country, but I think we are in a direction. So once you have this quantum computing knowledge, quantum cryptography knowledge, you become a quantum security engineer. As a starting salary, it starts with 15 lakhs per annum. There is a gap for quantum security professionals today in the industry. Even we here at Zenvi Quantum are looking for a couple of entropy engineers or photonic specialists quantum specialist. We're not finding any profiles. It's not about we are finding profiles, but those candidates are not good. No, we are not finding the profiles at all. And the next, as we start to see this hybrid mode, classic cryptographic algorithms and post-quantum cryptographic algorithms, the migration specialists or hybrid specialists, they are going to be in a very, very high demand because every organization, no exception, have to embrace PQC, have to set up their hybrid environments before they completely transition to post-quantum cryptography. But that's going to take a while. So therefore, the migration specialists are in demand. Right now, NIST has opened for certification also. So you can get certified for PQC. And I think, Zine, it makes sense for us also to start one PQC certification. This is a spontaneous thought process as I get to experience. We should probably be the first one to start, maybe from India, to provide this PQC certification for engineers, right? So, and our defense bodies are highly recruiting for quantum cryptography specialists, right? And many MNCs, they're starting their journey. So that's about what is the future of it going to be. And the domains, I think these we have been talking about it, right? Um, Defense, banking are the very first ones, followed by telecom and healthcare. For them, it is need of the hour. For them, it is need of the hour. So, and these four domains, if you see, any country needs to have it, right? Defense, undeniable, right? Otherwise, you will be taken over by some other country. Banking and finance, for your own internal stability of the government, for the everybody's day-to-day life to go smooth, banking and finance is unavoidable. So these two domains are the ones which are going to embrace the post-quantum computing, that is cryptography and QRNG first, and followed by telecom, because all your communication should be secured. And healthcare, as much as in India, we give a very least importance to healthcare, my health data. What he will do with my health data? Nothing, let him steal. Right? That's the kind of orientation we have it here in India. But in especially Europe and North America, it's a very, very serious thing to protect someone's health data. There are compliances like HIPAA to protect someone's health data. Nobody else other than the doctor who is actually treating the patient is allowed to see a person's health data, right? The PII, that is personally identifiable information. Here, if somebody asks, we give our phone number, our email ID, our age, whatnot, anything. It's free. If you travel in a train or in a bus, the aunt or uncle sitting beside, what is your salary? That's the first question. Hmm? Isn't it? So, what is your age? Oh, you're already 23-year-old, right? So, for us, our Indian culture is different. But when it comes to the North America and Europe regions, it's very sensitive, very sensitive. So hence, healthcare is going to be predominantly using post-quantum cryptography. That is where the need of PQC and as well as QRNG devices are going to be. Right. So, okay. So that's about the, a brief 10,000 foot height level of introduction, what I wanted to give today about quantum computing and quantum cryptography. All right. So now I would encourage you to ask me questions if you have. You can feel free to use the chat message, right? Uh, so we have our panel as well as our well-wishers, are in the chat. So you can start asking your questions. Again, as no question is a dumb question, right? You can ask anything. And then here are some of the questions that I put it up here for everybody's understanding. Even this question was asked when I was in Singapore. How far are we from Q day, the quantum day, right? So as I just said, maybe there my answer was 2030, but now in a week's time it changed. Ever since the Google has projected, their prediction is 2029 now. So the Q day is going to be in somewhere in 2029, and I wouldn't be surprised even if it moves, to earlier date. So is India using QKD anywhere today for this communication? So India is using QKD in some of the very sensitive defense systems, but it is not yet widespread. So it's not, no information is publicly available, but India is using, and China is using very, very much the QKD for secure communication. So can I integrate Kyber in Python now? So you guys tell me, right? So you can now think Kyber. So that's what I was saying. Yes, although these libraries available in C, C++, we need people to build it for Java. We need people to build it for Python. We need build it to integrate. We need people to migrate it. Yes, you can integrate Kyber in Python today. Maybe if your Python is your friendly language, yes, of course you should start experimenting with it. Right. So I'll pause there, and there is a question in the chat from or Sudhir. Uh, how does the quantum computing and blockchain come together? Yeah, so the underlying platform is same. See, blockchain is completely dependent on your public key and private key. Right? That is PKI, public key infrastructure, right? So the PKI is the fundamental platform upon which the blockchain operates, right? So now the private key, public key are at stake because the public key, private key are being generated using existing RSA DSA algorithms. Now, therefore, even the blockchain world should embrace the post-quantum cryptography. So that's the relation. The fundamental key generation is being impacted by quantum cryptography or quantum computing. So therefore, even the blockchain has to embrace the quantum cryptography. No alternative to it. All right, thanks for the question, Sudhir. And so, what should I learn first, QKD or PQC? So, for those who are in software, start with PQC. Those who are in triple E or ECE or more interested in hardware, start with QKD or rather QRNG2. So how does Kudo? Yeah, Kudo is our offering. Maybe I would ask our engineer Venkatesh Pulimamidi to talk about it in a while. Yeah, maybe why don't you talk right now? What Kudo offers, Venkatesh? Maybe PQC
Yes.
alone. Hmm.
Hey, hi Venki. Hi everyone. Yeah,
Yeah.
as Venki mentioned, yeah, PQC is a quantum post quantum cryptography thing. So it basically, uh, as you know, I'll give a little bit background of it. Like in a OpenSSL architecture. So as Venki mentioned, so these algorithms, classic algorithms, generate public key, private key, and all. So what this PQC provides is the crypto layer thing. The algorithms or whatever the OpenSSL tool calls, we can replace those crypto layer with our PQC so that we have our own implementations which are quantum safe. Like NIST approved couple of FIPS standards, that is FIPS 203, 204, and 205. Those are like MLChem and MLDSA and SLHDSA respectively. So on a high level, the first FIPS 203 is nothing but uh, it's a it is based on module lattice. It's a key encapsulation mechanism. On a high level, it is used for a secure key exchange. And the second one is for MLDSA, for digital signatures, which will be based on uh, module lattice. So it is quantum safe. So even quantum computers cannot break it. So that way, client can securely authenticate the server. So we use certificates for the server authentication by the client. So that those are quantum safe. The third one is like SLH DSA, as mentioned earlier by Vinky. Like even hash algorithms like HMAC can be breakable by quantum computers. So even to secure our sensitive documents. So in the industry, some of the legal documents and defense or whatever it is. So wherever the sensitive documents are there, they should be protected very well for a long period of time. So in such case, this algorithm is a good one. So it can provide a security for uh, several decades. I can say 20 to 30 or whatever. So it is unbreakable. So if we sign a particular sensitive document, it can be verified after 50 years as well. So the integrity. So that's how it is quantum safe algorithms. So those are the three implementations. We are currently working on it. Yeah. Thank you,
Venkatesh.
Venki.
So thank you very much. So probably you can share our link, PQC link in our chat so that people can go through. Hey guys, our PQC, Qdo PQC is now publicly available. You can download, follow the instructions and experiment. Maybe if you have questions, reach out to us. Right. So that's about this question, PQC versus QKD, which is more practical. Both are practical. There is nothing theoretical here, right? Whatever we talk today, PQC, QHSM, QKD, or QRNG, everything is practical, right? All of them are today in implementation. And PQC, as you know, that's a good news. You can take this, go through the link that Venkatesh posted in the message and download and then play with it and reach out to us for any questions. Even if you are interested in doing what do you call the test or PQC kit, you are welcome to do so. So is quantum crypto affordable for SMBs? So small, medium businesses. Yeah, quantum crypto as on today, the hardware side, QRNG, QHSM, QKD are going to be expensive for SMBs. So I don't say that they are affordable for SMBs, but PQC is something on the software stack, it is affordable. So which certification matter for this field? Yeah, so for this field, especially if you are developing a product, NIST certification is mandatory. It is going to help. And for hardware side, we have few other bodies. So their certification, that is from the product point of view. From the certification as a student, right? IBM is offering one detailed course. And then as Zenvi, we are tied up with IBM as well. So we can also offer a core certificate on quantum cryptography going forward. And then, yeah, so here is our social, thank you everyone for joining and join our, WhatsApp community if you're not already there, and connect to us on LinkedIn, Instagram, Twitter. I hope this session gave you some introduction, some new terminology, new language to you. Thank you, everybody, and have a happy Saturday.